beginning with some of the special centers of a triangle. The first one we're looking at today is called the circumcenter, and the circumcenter is a place on the center, or a place on the triangle, I should say, that is equidistant from all vertices of the triangle. So at this point right here is the circumcenter. It means if I draw a line from it to all three vertices, all three of these are going to be equal in length. So if I call it point P, that means PA, PB, and PC are all the exact same distance from, they are the all same distance. They're the same length, the same segment. Now, the circumcenter can be found, and we'll talk about this more as the day goes along, by finding the perpendicular bisectors of each segment. So if I take the perpendicular bisector of AB, which means it will go something like this, and then for this one for BC, and this one for AC, where they intersect is where the circumcenter ends up. So we'll find it by using these perpendicular bisectors. So to solve some problems with it, say we have a triangle like this, and we say Z is the circumcenter. So what does that mean? Well, that means that each of these small segments are perpendicular bisectors, so they are all right angles, right triangles being made. And then each of these long segments, GZ, HG, or GZ, HZ, and JZ are all the exact same length. So right away I can say, well, if GZ is 19.9, JZ and HZ needs to be the exact same thing. So I can plug in those as 19.9 immediately. Similarly, if MJ over here is 14.5, that means GM, because this was a bisector, cut it in half, this must also be 14.5. Now, HL is this segment up here, which we don't know, and KZ, this segment right here, we don't know. One common mistake is a lot of people will say KZ is equal to 9.5 because the bisectors must be the same length. That is not the case. The bisectors do not have to be the same length. To find what the length of KZ is, let's look at this triangle here that I'm going to outline real quick in green. Looking just at that triangle, if I redraw it, it is a right triangle, and I have, well, here's KZ, I don't know it, let me call it X. This side over here is 18.6, and this final side over here, this is the side that is all the same as GZ, that's the 19.9. The way to find X, we have a right triangle, we need to use Pythagorean theorem. Remember, the hypotenuse, one across in the box, needs to be by itself. 18.6 squared plus X squared equals 19.9 squared. Plug those into your calculator, do subtraction, you'll get X squared will equal whatever 19.9 squared minus 18.6 squared is. You take the square root and you get X is equal to 7.07. So that's how you find what KZ is using Pythagorean theorem, 7.07. Same thing here to find HL. That's this segment over here. I'm going to use this right triangle now. And it's set up very similarly, almost the exact same way. So I have the triangle that looks like this. I don't know what this is. I'll call it X. Or I'm sorry, this is one I don't know. HL going up and down. ZL I knew was 9.5. And then this hypotenuse again, same thing, was 19.9. So very similar setup. 9.5 squared plus X squared equals 19.9 squared. Do the subtraction, you get X squared equals whatever that subtraction is. It's about 305. And when you take the square root, you should get X is equal to 17.48. So HL is 17.48 for that. So those are just some things to look for. Mainly look for, can we find these middle segments, because all three must be the same, and each of these sides of the triangle get cut in half. Now, one final thing to look at with the circumcenter is, again, if I were to draw it that this is the circumcenter, that means all three of these segments going to the vertices must be the same length. So that means, think of this as a real center of a circle. That would mean each of these segments would be a radius of the circle. So a circle would look something like this, going all the way around, a very poorly drawn circle, but essentially it's a circle that has all three of these points on that circle. This is called the circumcircle. And this this should make sense. A circumcircle, things like circumference going around, circumnavigate going around, it goes around the triangle. Later on, we'll do something called an in-center, which will have a circle that is on the inside of the triangle looking like that. That's something we'll take a look at in the future, but just think for now that circumcenter, circumnavigate going around the circle, and that's found by using our perpendicular bisector.